Okay, grade 11s, here is your first video on Euclidean geometry. We're going to go through all the circle geometry theorems that you need to know. By the end of the series, you should be covered. I'm going to probably do like between 2 and 3 theorems a video. We'll just see kind of how long the time takes to get through them. But yeah, okay, so let's just start with theorem 1. Theorem 1 says line segment through center and midpoint. Okay, so basically what they're going to say is that a line drawn from the center of the circle perpendicular to a chord bisects the chord. Okay, so you need to prove that that perpendicular line bisects the chord. Okay, so a little bit of remembering here. A chord would be this line over here. So from one point in the circumference to the other point over there. Okay, this is your center. So they essentially are saying that this line from the center is drawn down and perpendicular. Okay, and they want to know, or they want you to prove that because you've drawn a line from the center perpendicular, it is bisecting. So in other words, making those two lines equal to each other. So we are proving that these two lines are equal to each other. Okay. So what we're going to use to do this is congruency. We're going to prove that the two little triangles are congruent. Okay, so if you can see, you've got a triangle here, and you have a triangle there. Okay, now we constructed that triangle. So over here it says construction, join OA and OB. So we drew in this line over here, OA, and you drew in OB. Okay, so that's what you need to do before you even start. Okay, so your question, whenever you're proving something, you're always going to write RTP and what you're proving. So they've done it here for us. Required to prove, which is RTP, AD equals AB. That's what we are trying to prove, that AD equals DB. These two lines are equal to each other. So before you start with the proof, you first write RTP and what you are trying to prove. Okay, then they said construction. So they've constructed OA and OB. Okay, so now we're just going to get started. As I said, we're going to use congruency. So we're going to start by saying that, do you agree with me, if this is the center of the circle, this is something else I need to explain. This is the center of the circle and this is the circumference. This line must be equal to this line because it's a radius. Remember, radius is the point from the center to the circumference, and a radius is equal all the way around from here to here, there to there, there to there. Your radius is always equal. Okay, so we can start by saying, so number 1, we can say OA is equal to OB, right? And whenever you are using the fact that it is a radius, in other words, they're both radius, so they must be equal to each other, you're going to say radii as your reason for that. Radii is the plural of radius. So you're going to say radii every single time you're using the fact that two lines must be equal because they are both radii. That's what you're going to write in the bracket. Okay. Point 2. Do you agree with me that angle D1 is equal to angle D2? They are both 90 degrees. So we know that they are equal. So you're going to say angle D1 is equal to angle D2. You can say given, or you can say maybe OD is perpendicular to AB. So we know therefore that those two angles are equal. And then lastly, OD is common. You guys agree with me? That line is common between these two triangles. So you can say OD is common. Okay, so now you've got 3 things. Remember congruency, there's 4 ways to prove congruency. I think I'm going to leave that up to you to go and remember and check out. But you've got, this is a right angle triangle, so you've got the hypotenuse, you've got the side, and you've got the right angle. So the way that we've used is RH, it's right angle, hypotenuse, and side. So you say therefore triangle OAD is congruent to triangle OBD because RH S. We used right angle, hypotenuse, and side. Okay, so therefore, if they are congruent, AD is equal to DB, and that is what we were trying to prove. If these two triangles are exactly the same and they're exactly equal to each other, then those two sides must be equal. In the process of proving congruency, I hope that none of you were tempted to say AD is equal to DB. You cannot use that as a reason when that's what you're trying to prove. So just make sure that whatever you're trying to prove, you never ever use that as a reason. Okay, so that was simple enough. We used congruency to prove it. Okay, so just make sure that you draw this and you draw the whole explanation. Also, in examples, when you're actually using it, let's write it in a different color. When you actually decide to use it in answering questions, your reason is going to be line from center perpendicular to chord. So what I mean by reason is, you know how we said that these two lines are equal to each other because radar. So if you're ever wanting to say these two lines are equal because of this theorem, that's going to be your reason in the bracket. Okay, I don't think I have a page with this on, but just so you know, the reverse is also true, the converse, that's what we call it. So let's write down converse. The converse is also true. There's an R missing, sorry, converse. There's an R in there, it's just looking ugly. The converse is also true because if they told us that so let's say it looks like this. This is your center, here's your chord. They draw a line down and they say these two are equal. Because we know the two are equal, we can say it's also perpendicular. So instead of saying it was perpendicular, therefore it's equal, it's now because it's equal, it is perpendicular. So if you're using the converse, your reason's a bit different. Your reason is just going to be line from center, and then you can maybe say bisects chord, or yeah, bisects chord is good. Bisects chord. Then you know it is perpendicular. So just make sure you understand that this can work the other way as well. Sorry, I've actually just double checked. They've written line from center to midpoint of chord. So line from center to midpoint, but you can use either one, doesn't matter. Midpoint. It's getting untidy. Okay, cool, but this is generally kind of the one you're going to use. Okay, so next let's do an example. So they've given us a circle here. We can see that this is a line from the center, it's perpendicular to the chord. So before I even read my question, I'm already going to do this for myself because I think it's going to help. I know those two are equal. And why are they equal? If I look at this, line from center perpendicular to chord. This theorem tells me that because it's perpendicular, these two lines must be equal. Okay, now let's read the question. It says QR is 24, PS is 5, P is the center of the circle, determine the length of ST. Okay, so they are wanting us to find, do I have any highlighters? Let's get a highlighter. They want us to find this length over there. Okay, now when I see that length, my brain took note of the fact that this is a radius, right? A radius. So if you think about it, that PT is the same length as PQ, and it's the same length as QR. Try and look for all your radar because they really help you. Okay, now let's just write in what they said. So they said QR, this whole length QR is 24. And they also said PS, this little piece of PS over here, is 5. Okay, I hope by now you're starting to see what you could do. Because this whole thing is 24, we discussed that these two pieces must be equal. So do you agree that both of these, this would be 12, and that would be 12, because half of 24 is 12 and 12. And now that you've got 12 here and 5 here, and this is a right angled triangle, don't you agree that we could get this as a hypotenuse? Right? We could get this 12 squared plus 5 squared must be hypotenuse squared. And remember, we've just discussed the fact that PQ is the same length as PT because they are radii. So if I find this length, I'm also finding that length. Right? It's quite simple. Okay, so every single step that you take, everything that you do, you need to give me the reasons why. So let's say we're going to start by explaining what so I've done it verbally, but now I need to write it down. QR is 24, right? So in order to say that QS is 12, I need to explain why. So I'm going to say QS is equal to QR, right? Those two lengths are equal. Why? Because line drawn from center perpendicular to chord. Correct? Line drawn from center perpendicular to chord bisects these two. That's why those two lines are equal. We've just done that theorem. Okay, so therefore, I can say QS is equal to 12 centimeters. Okay, because we know those two lengths are equal. All right. Now I already know what PS is, so now I can go and use Pythagoras to find PQ. So PQ squared, by the way, it doesn't matter which triangle you work in. You could have said QR squared and PS to get this line. Doesn't really matter. But anyways, let's just use that one. PQ squared is 12 squared plus 5 squared. So essentially I'm working in this triangle up here, 5 and 12 to get the hypotenuse. Okay, so therefore PQ squared is going to be squared plus 5. It's going to be 169. And then the square root will just be 13. Okay, so I know that PQ is 13. What are they actually asking us? They're asking us about ST. But now that I know that PQ is 13, I also know that PT is 13 because this is also radii, and I know this piece is 5. So if I just want that little piece, this section over here, and the whole thing is 13 and that's 5, what do? I just need to subtract. But before I can do that, I first need to explain why PT is also 13. So I'm going to say PT is equal to PQ, which is equal to 13 because radii. Remember, they are both radii. So now you can say, therefore, ST is equal to 13 minus 5, which is, oh, why am I using a calculator? This is only 8 centimeters. Okay, does that make sense? We went and we found this length. I mean, they're lying on the same line, so 13 minus 5 would give me 8 centimeters. All right, so we used our theorem that we've just learned, line drawn from center to perpendicular to chord. We've just used theorem 1. Okay, so just make sure you understand what theorem 1 is and how it works. Okay, all right, second example on the same work. This one's a little bit more tricky. What I'm going to do is I'm going to go through all the different theorems, and then afterwards I'll do some exam paper questions because it's quite challenging going from the theorems to the actual exam questions. Okay, so now they give us a circle. They say OE is perpendicular to AB. So that immediately should ring a bell in your head because this is a line drawn from the center. O is the center, and it's drawn perpendicular to a chord. So your brain should know that those two lines are equal. Let's use a double one. Okay, so if you're going to use that at some stage or another, you need to say why. You need to use that line drawn perpendicular to chord as a reason. Okay, then they say CF is equal to FD. Okay, so they've drawn this one and they're saying this line is equal to that line. And it's also drawn from center to midpoint. So what does your brain tell you? It's the converse theorem of theorem 1. If these two lines are equal and it's drawn from the center, we can now say that that must be perpendicular. It's like the reverse. And remember, if I use that, I'm going to have to say that I need to use that reason. What did they say? Line drawn from center to midpoint. Okay, so if you're going to use either one of these things I've drawn in blue, you need to say why. Okay, then they tell us OE is 63 centimeters, so this whole little piece here is 63 centimeters. They tell us FE, this piece over here, is 3 centimeters, just this little section. And then they tell us AB, this whole piece, is 2x minus 18 centimeters. They've got some x's in there. And then they tell us CD is 2x. I'm not going to write them in because it's just going to take up space, but I'll refer back when we find them. Okay, so then they say determine the length of the radius. All right, now what I want you to do is again go and highlight your radar. It makes your life easier. So here's the center. Here is one radius, excuse me. Here's another one there. This isn't a radius, it's short. Okay, so these are our two radar. All right, so we are trying to find the length of those. Now, I want you to think about the fact that we know that, you know, these two pieces are equal. We know that these two pieces are equal, whether they've given it to us or they haven't, but we've been able to figure out that these two pieces are equal. They've given us that CD is 2x, and they've given us that AB is 2x minus 18. So they've given us some kind of information about these two lines. So if I just wanted this thing, let's say this whole thing is 2x now, and I just want half of it because I want to work with these triangles. Half of 2x would just be x. Then AB was 2x minus 18. Half of that will just be x minus 9. I'll show you when we divide it by 2. Okay, and then think again about the fact that we're working in right-angled triangles here. Okay, here's a right-angled triangle, there's a right-angled triangle. So you guys agree with me, this whole thing is 63 centimeters. They told us OE is 63. They told us this piece is 3. So if the whole thing is 63 and this piece is 3, what is this? This must be 60, because it's 63 minus 3. So that must be 60. Okay, so now for both of these triangles, for this, if I'm working in this triangle over here, okay, I know this is 63. I know this must be half of 2x minus 18. Okay, and then in this little triangle, I know it's 60, and I know this must be half of 2x. So I've kind of got information about two sides. And remember, when I look at these radar, you can see that these two lines are equal. They're both equal, and they're also both hypotenuse, because if you look at the right angle triangles, they're hypotenuse. So if I use Pythagoras, I say this side squared plus this side squared equals hypotenuse squared. And I look at this triangle, this side squared plus this side squared gives me hypotenuse squared. Both of those hypotenuse squareds are exactly the same thing. They are equal. So what I'm going to do is I'm going to set these two equations equal to each other. Okay, so let's first go and write in all the information that we gathered, because you can't just get to the answer, you need to give reasons. Okay, so let's start by working with triangle OEB. We're trying to say that this, we want to explain what EB is equal to. Okay, so first of all, I'm going to say AE is equal to EB. And why is that? Okay, and you can even go and divide it as well, which equals to, remember this AB is 2x minus 18. So 2x minus 18 divided by 2, because that's the whole length, so we just want half of it. Okay, which then equals 2 divided by 2 just disappears. 18 divided by 2 is 9, so this equals x minus 9. Okay, and how could we say that these two lines were equal? What was my reason? Line drawn from center perpendicular to chord. Okay, so that's where that piece of information came from. I knew that this was x minus 9, this whole thing divided by 2, because my theorem says if I have a line from the center drawn perpendicular to a chord, it bisects the chord. Okay, now let's do the same thing for triangle OFD. We know that this piece is, the whole thing is 2x, so that piece must be x. Okay, so I'm going to say CF, this line, is equal to FD, and we actually knew that because it was given, right? But anyways, it equals to, remember they said CD is 2x, so it must be 2x over 2, which is just x, and we knew that because it was given, correct? They told us those two are equal. Okay, so now I've already got an expression. We know that this EB is x minus 9. We know FD is just x, we worked that out. Now, before I can go and do Pythagoras, remember, I drew in this right angle. How did I know it was right angle? Because of the theorem, the converse of theorem 1. So I'm going to say angle F is equal to 90 degrees because line drawn from center to midpoint chord. Okay, so it started from the center of the circle, it was drawn to the midpoint, it was drawn halfway, so therefore it must be perpendicular, it must be 90 degrees. Okay, so now I have everything I need to go and work out what x is. Remember I said both of these, OD and OB, are equal to each other because they are radar. So before I can continue, let's mention that. So OD is equal to OB because radar. You with me? Okay, so let's come up with an expression for OD. OD is going to be in the, okay, let's look in this triangle now. So this triangle, there, is going to be this side squared, which is 60. 60 squared plus this side squared, which is x squared, because Pyth. Okay, and then we're going to do the same for OB in this triangle. There's OB. So OB must be this whole length, which is 63. 63 squared plus this side, which is x minus 9 squared, because Pyth. Okay, I'm actually running out of space. Get another page. Might land up doing one theorem after all, because this is going on for quite a while. Okay. So now we have an expression for, let's go from here. We have an expression for OD, and we have an expression for OB, and we know that OD is equal to OB. So I can make these two expressions equal to each other. Let's switch up the color. Okay. Alright, so now it's a case of working out, but I'm just going to write them next to each other. 60 squared plus x squared is equal to 63 squared plus x minus 9 squared. I don't need to write a reason because I wrote it over here. I said OD equals OB because of radar. So now let's go and calculate. Okay guys, to save a little time, I just quickly did the trinomial. But remember, this just gives us the solution to x. So we still actually, the question was determine the length of the radius. So just bear in, you can use any one. So let's say OD equals 60 squared plus x squared. Sorry, it was actually OD squared. These should all be squared. Or not that one, but these two should be squared. Because remember, it's hypotenuse squared equals side squared plus side squared. So just make sure you correct that. Okay, so to get OD alone, it's going to be the square root of 60 squared plus x squared. But we have an expression for x, so you can replace x plus 25 squared. So OD will be equal to the square root of 60 squared plus 25 squared, which is 65. So the solution to the length of the radius is 65. Okay, you could have used OB as well. You could have replaced that x with 25 and worked out OB, because OB and OD are equal and they're both radar. Okay, I think I'm going to do a different video for theorem 2 because these have gone on a bit longer than I expected, but I hope that you guys understand.